Hello everyone, welcome back, and today we are looking at question 268, which is missing number. So we are given an array nums containing n distinct numbers in the range 0 to n inclusive. Now we want to return the only number in the range that does not appear in our nums array. For instance, if we pick n to be 3, this means that our range would be from 0 to 3 inclusive, right? From 0 to n inclusive, n is 3, our range would be from 0 to 3 inclusive. Now, this means that our range would be 0, 1, 2, and 3. So we notice that if n equals 3, our range will contain n plus 1 numbers, right? If n equals 3, because we are starting from 0 and 3 is inclusive, we would have 0, 1, 2, 3, which are 4 numbers. Now, our nums array, they are saying that nums would only contain n numbers. So if n equals 3, our nums array would only contain 3 numbers. So we will pick any 3 numbers from the range to fill our nums array, right? So the example one is saying, okay, let's pick 3, let's pick 0, and let's pick 1. Now we can see that nums only has n numbers, in this case n equals 3. So okay, if the range is n plus 1 and the nums contain only n, we can see that the range has one extra element that is missing from nums, and this is the number we are trying to find. Okay, so how can we find the missing number? Well, let's see. If this is the range, we can add all the numbers in the range, and let's call that sum range sum. So this is range sum, and let's call this one the actual sum. So this is the actual sum. Okay, now if we add all these numbers and we in the range, and we add all the numbers in the nums array, and we subtract the two, we can clearly see that 0 will cancel out with the other 0, the 1s will cancel out, 3s will cancel out, we will be left with the 2. So we can see that, okay, if we have 0 plus 1 plus 2 plus 3, and we have 3 plus 0 plus 1, now if we subtract these two, we can see that 0 will cancel out with the 0, 1 will cancel out with the 1, 3 will cancel out with the 3, 2 minus 0 equals 2, and this is the missing number. And this is the problem, that's it. So let's try to code this solution quickly, and then I will show you a quick modification for how to calculate the range sum to make this to make our approach even faster. So let's have a look. We will have two sums. We will have the range sum, and we will have the actual sum. So the range sum will start from 0, we can initialize it to 0, and we can have the actual sum also initialized to be 0. So actual sum equals 0. Now, what is the length of our nums array? Well, we said our nums array would contain only n numbers, and in the constraints we can clearly see that the nums.length, which is the length of our array, is n. So instead of typing nums.length each time, let's just say int n equals nums.length. Okay, good. So now let's try to find the sum of the numbers in our array, which is straightforward. So for int num inside of nums, we need to add all these numbers to the actual sum. So actual sum plus the num. Good. And now we need to calculate the sum of our range. So we will have a for loop for that. So for int I equals 0, I is less than n. But now wait. If we say I is less than n, we will say 0 plus 1 plus 2. And we will miss the 3. The question is saying that the range is from 0 to n inclusive. So we need to include the n, which means I is less than or equal to n, and I plus plus. Okay, so now what do we need to do? Well, we can say the range sum plus the plus I. We need to add each number to our range sum, And that's it. At the end, just return the range sum minus the actual sum, and we would get the answer. So that's it for this approach. This for loop runs in big O of n time. This for loop runs in big O of n time. So the time complexity is big O of 2n, which can be of course reduced to big O of n. But we can use something different to calculate the range sum. So let's see how this goes. So first remember, this approach is big O of 2n, which can be reduced to big O of n. So now let's see how can we modify this one to calculate the range sum in constant time, big O of 1. So let's have a look. So we can see that the range is 0, 1, 2, and 3. Now, when we are talking about the sum of the first natural numbers, we always need to think about Gauss's formula. Now, what is Gauss's formula? Well, let me write it first. So we have Gauss's formula. Now, when you hear this term, always think about the sum of the first n natural numbers. So first question, what is a natural number? Well, the natural numbers denoted like this are the numbers from 1, 2, 3, 4, up to infinity. These are the natural numbers. Now, if you want the sum of the first n natural numbers, Gauss is saying this sum is equal to n times n plus 1 divided by 2. Let's see an example. Let's say n equals 4. We want the sum of the first 4 numbers. Now, if we would have this for loop that will go through all these numbers, we will have, okay, 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10. We use the for loop for that with time complexity big O of n. Now let's check Gauss's formula. Since we need the sum of the first 4 natural numbers, we would have 4 times 4 plus 1 is 5, divided by 2, 4 times 5 is 20, 20 divided by 2 is 10. We got the same answer, but Gauss's formula gives us big O of 1 time, right? So now let's modify our code. We don't need this for loop, no need for it, and now the range sum, instead of having it initialized to 0, we will say, oh, by Gauss's formula, we can say n times n plus 1 divided by 2. And that's it. So now let's try to run the code. Okay, and now let's submit. As you can see, faster than 100%. So we have one for loop to calculate the sum of our nums array, which is big O of n time. Now, by Gauss's formula, we can calculate the sum of our range in big O of 1 time, constant time. So the time complexity of this, big O of n. The previous approach was big O of 2n, which got reduced to big O of n. This one is big O of n right from the start. So this approach is faster. Now, let me say that this question can be solved in bit manipulation. And on my channel, I have already made 2 videos that goes into great detail into bit manipulation. I will put the links for those videos in the description. And if you watch those videos, this question would be walk in the park to do it in bit manipulation. With that being said, I hope you guys enjoyed the video. Best of luck to you, and I will see you on the next one.